Alexander Lauterwasser is a photographer who makes captivating images of water under the influence of sound vibrations. As a child, Alexander raised tortoises at home in Heiligenberg, Germany. He came across illustrations of Chladni sound figures that bore a striking resemblance to a tortoise shell.
Die, und das war das Überraschende für mich, sehr enge Verwandtschaft haben mit Strukturen in der Natur und besonders hier mit dem Schildkrötenpanzer.
Chladni figures are named after Ernst Chladni, an 18th century musician and physicist. He spread sand on metal plates and played them with a violin bow. The vibrations from the bow caused the sand to gather into beautiful geometric forms. Next, Alexander discovered the research of Hans Jenny, a Swiss physician, who took up and expanded on Chladni's work in the 1960s using fluid mediums and electronic amplification of sound. Jenny coined the term Cymatics, from the Greek for wave, for this branch of study. Today, Alexander Lauterwasser is building on the work of his predecessors, employing modern sound and recording equipment. He has custom-built devices which allow him to stimulate various materials, such as sand or water, with sound vibrations whose frequencies can be precisely controlled.
Um das Ganze auch dokumentieren zu können und festhalten zu können, wird es hier mit einer Videokamera gefilmt. Wenn das alles richtig eingerichtet ist, gehe ich an den Frequenzgenerator, beginne mit einer relativ tiefen Frequenz.
The sand is pushed from areas where the vibration is strongest and collects where it is the weakest, forming patterns that correspond to the particular tone that is applied to the plate. The higher the frequency applied, the more complex and detailed is the pattern that results. Under controlled conditions, these forms are repeatable.
very rare that you get elliptical shapes. You know, most of the
circulars.
Mostly so, but you're getting elliptical shapes in track 1. But wait till you see track 2.
Okay.
It is absolutely amazing.
That of course is me. Wow.
Window into another dimension.
Cut 11 was very interesting.
Cut 2 is amazing because this second track is just like, it freaked me out completely. I've never seen anything like it.
Wow.
Wait till you see this. Amazing! I have never seen anything like that. Never. Oh, I'm so moved by it.
Here is one of these forms. The material travels inwards from the edge along the bottom of the pile, rises up in the middle, and is then carried back to the periphery. Even if the intensity of the vibration changes, there is still a whole system of radial circulation. At certain frequencies, or with certain tones, an extraordinarily interesting phenomenon is seen. Watch. We see two regularly and continuously rotating areas at either end of a diameter, going round and round like weathercocks. This is the expression of a rotating wave motion. We can see they are rotating in an anti-clockwise direction. We now switch to a different frequency and produce the same phenomenon, but this time in a clockwise direction, because the frequency is different. If we go back to the previous frequency, we have the same phenomenon again in an anti-clockwise direction. Notice that this rotary movement does not affect the circulation or convection in the least.
When the wavelengths are short, these currents produce a rotary effect. Areas become defined in which the particles are actually rotating. In vibrating glycerin, we see the extraordinary things we see here are simply and solely the effect of vibration.